Good. All right. So this is this Wireshark challenge, and the second half is from the Red Team Village, this APT capture, which is a good, fun thing to play with. And so here it is, and it tells you in the corner how many packets there are, 72,000 packets. So this is a real attack with many stages. And so the first question is, what are the encrypted protocols? And for that, you can use statistics and I think protocol hierarchy, yeah. And you kind of need to do these all more or less in order. Protocol hierarchy is here. So you can see all the protocols in the packet, in the PCAP, and you can see most of these are not encrypted. The only encrypted ones are TLS and SSH. And SSH has just one packet with a few bits. TLS is the one that has a significant number of packets. And so, if you want to examine this, you can apply as filter the selected, and then close, and now you'll get that traffic here, and you can see it's only a small certain packets, and you can see the port layers. If you go down here to transport layer security, and here to TCP, what you can notice is it's going to port 8443 instead of 443, which is the normal for TLS. And so that's the first clue of something interesting. So now that you know that port number, you can then look for the traffic. That means somewhere something started a listening process at 8443. And therefore the command line that did that probably contained that string. So you can look for packets that contain that string with frame contains 8443. And now you get traffic, and this is what's interesting. Now you see there's a group at 2,000, group at 26,000, then another group at 46,000. Now the way examining packets one by one will make you go crazy in Wireshark. What you want to do is follow a stream to see what people did. Now here there's just 2 packets, that's not even worth looking at, nothing much happened. Here there's enough packets where something happened, so you right click and follow TCP stream. And you'll see more or less what the users saw. So this is a web page loading with 200 OK, and the blue is one direction of traffic. This looks like from the server. And it's just one big long web page. So that's not very interesting. So I'll forget that one, and I'll go back to re-implement the filter, because it's when you follow the stream, it replaces the filter with a different filter. So let's get back to here. So we're ignoring this, we're ignoring that. Let's try this stuff at 40,000. Right click, follow TCP stream. And now this is the bad guy hacking the machine. The blue is what came from the server, the red is what the bad guy did, and this is really normal. Once you get in, there's standard things you always do when you hack. You gather information. First you find what privileges you have, then you find what operating system is running, then you look for the IP information, then you look for the running processes. This is the steps of the hack. Then you're going to do something like enumerate, go to the file system, and here he is. He is now doing a listening port. He's going to listen for traffic coming in and feed it into a file called SOCAT. So he's going to get SOCAT from some remote server and push it down onto this machine. So he wanted this, and this is a utility. So he used SOCAT, then he looks to see if he got it, and he did get it. Then he creates an SSL key, then makes sure that that key is really there with the LS. Then this is the command that creates the other part of the SSL key. You have to make a key, and then you have to convert it to another format. That's what he's doing here. And then, after he's done all that, he now puts the secret key in a file in the right format, and then he sends it somewhere over the network. This is why you're totally going to be able to reverse all this. You can see the tool he's using. It came in unencrypted over the network, and his secret key is sent unencrypted over the network. So you're going to be able to decrypt all of his traffic later. And this is the command that creates, yep, this is it. This is the command that starts listening on 8443 using the key you just created. This is what makes an HTTPS server with a self-signed key, so he can now use encrypted communication for his future hacking. But since he sent the private key over plain text, you can steal the key and decrypt his encrypted communication and find out what else he did. And that's why it's a fun project. But this is the heart of it all. This one here lets you totally see what he did, and it answers several flags. You can see the tool he used and things like that. And you can even get the exact binary of that tool and calculate the hash, and I think that's one of the flags. And then what's fun is you can decrypt it in Wireshark, which is possible, although surprisingly difficult. Wireshark has like 2 different places to put encryption keys in different versions, and it's confusing which one to use. But you can actually add the key to Wireshark, and then it will show you the encrypted TLS, and it'll decrypt it on another tab. So anyway, that's the fun part of this one. But this, I think, is the main thing where people get stuck. If you don't find this, you're pretty much lost. This is where you see the general story. Yeah, and that's good. I'm glad you brought it up. Let me stop this one.